We are working on A78 and we are doing dividing rational expressions. So it's honestly nothing new, but we talk about dividing. We're not going to divide. We're actually going to multiply by the reciprocal. So instead of dividing by a fraction, we multiply by the reciprocal. Some people like to use the term keep, change, flip. So let's talk about what that means. I like the math term. Instead of dividing, multiply by the reciprocal. What's a reciprocal?
I don't know.
When you flip the fraction. So if your fraction is a over b, the reciprocal is simply b over a. That's all you do. All right, so we are inverting the operation and inverting the fraction. So keep the first fraction, change the sign. So it's 1/2 times, and then flip the second fraction. So it's not what you want to flip. It is keep the first part, change the sign, flip the second fraction. So instead of dividing by a fraction, we multiply by the reciprocal. Now, you have two options here. You can just multiply the numerators. 1 times 4, 2 times 3 is 6, and then you can reduce. They both divide by 2, so 2/3. Or you could use the idea of cross-canceling. Whenever you're dividing, you can't do anything, but once you change it to multiplication, you could say, hey, 2 goes into 2 once, it goes into here twice, and there's my 1 times 2 is 2, and my 1 times 3 is 3. All right, so we're really not doing anything new because prior to break, we just multiplied. We are taking this division and changing it to multiply by the reciprocal. So we're really just going to multiply again. We have an extra step to do in front. It says, assume that all expressions are defined. We're talking about variables in the denominator. You can't divide by 0, so we'd have to define that x and y can't be 0. We were focusing on just the algebra, not the variables. So keep the first one. I'm not even going to, you could come in and reduce each fraction, but we cannot cross cancel. But I'm just going to keep that first fraction. 4x to the third over 9x squared y, and then change the sign. So keep, change, flip, and the flip would be 9y to the fifth all over 16. Now you have two options here. One, you could just multiply the numbers in the top and the bottom and then reduce. And I'm fine with that. I'm going to do a mix of this. I'm going to cross cancel because 9 and 9 divide out. I'm left with 1, and 4 and 16 reduce. 4 goes into 4 once, and it goes into 16 4 times. So number-wise, in the numerator, I have a 1 times 1, which is just going to stay 1, and the denominator 1 times 4 is 4. What about the variables? Let's clean those up. In the top, I have an x to the third and a y to the fifth. In the bottom, I have only x squared and only y. So if you want to, you could have cross-canceled your variables and your numbers at the same time, but I would like to reduce my numbers so they don't get too big. And then I'm going to clean up all the variables and then cancel. Who has more x's?
The top.
The top. So we're going to take out 2 of these and we're left with x to the first on top. Who has more y's?
The top.
So there's 1 down here, take it out, and there's 4 left here. So when you go to do this, keep your top as a 1x y to the fourth. And in the bottom, all you have left is a 4. Now, the rule with division is when you're dividing, you take the power in the numerator and subtract the power in the denominator. That would give us our x to the first, and you would have y to the fifth minus 1, and that would be our y to the fourth. So final answer, I don't need the 1 out front, but I'm going to go ahead and keep it. Okay, now b looks a little bit different. So here we had just a fraction with the division symbol, but this is truly a fraction also divided by a fraction. These are called complex fractions. I'm going to keep the 5y over 3x squared, and instead of dividing, I'm going to flip my sign to multiplication and then flip this to be 10x to the fifth over 2y to the third. So I didn't rewrite this, but I could. This is really 5y over 3x squared divided by this. So we could have it written as a vertical fraction or right here with the division symbol. Okay, any way you cut it, again, you could just multiply everything together. So if you want to do this, you take your 5 times 10 and say that's 50, and keep the x to the fifth and y to the first. I have a habit of going alphabetically. You could take your 3 times 2 and say that's 6. Keep your x to the, is that supposed to be 2? And y to the third. So I just cleaned it up. Now, once you clean it up, you're going to have to reduce it. So number-wise, 50 and 6, how do they reduce?
2.
Just a 2? Double check if you can go bigger, but I agree with your 2. So I'm showing what's left, 25 and a 3. All right, x's, if we subtract, we'd have x squared, or x to the third. But really, I'm knocking out 2 of them, and I have 3 left on top. What about the y's? Who has more y's? Yeah, so I'm going to take out this 1, and that leaves me 2 on the bottom. So you have to pay attention to where they're left. That is your final answer. There's nothing else to reduce. If you were using the rule of subtracting, you'd have 1 minus 3, and you would have gotten y to the negative second, and then you have to move it. That's why I like to just cancel. Okay, how do I know I'm done? My numbers don't reduce, and my variables only show up in one place each. Now, if you come back over here, you could have cross-canceled. 5 and 3 don't reduce, 3 and 10, but the 2 and the 10 would have reduced. You could have cross-canceled the y's and been left with the 2 down there and the x's. So if you're comfortable with cross-canceling and then what you need to do to clean it up, you're good. But if it's too much and you lose things, better to put it together and just reduce it. Okay? Okay. So I would like you to try example 1A. As soon as I see a division symbol, I'm not canceling anything. I'm going to keep, change, flip. So as soon as you do division, keep, change, flip, and then see what you can reduce.
You just told me to keep, change, flip.
So as soon as I see division, I'm going to keep everything there, change the sign, and then flip that fraction. Whoops. X to the fourth, y. Okay. When I'm going to do this, again, you could cross cancel. So if you're comfortable with this, I see the 4 and the 12 reduce. 4 goes into 4 once, it goes into 12 3 times. So if I'm looking at my fraction, number-wise, I have a 3 and I have a 1. Now, some of you are comfortable with this, and you could cancel and say, hey, I'm going to take out 2 x's and take out 2. So x squared is left on the bottom. I'm going to take out 1y and 1y, and that means there's 1y left on the top. So if you're comfortable cross-canceling, that is a shortcut. It's a little bit less writing. If you're not comfortable cross-canceling, once you keep, change, flip, you're going to clean up the top. And you're going to say, I have a 12, x squared, y squared. So everything's cleaned up, put it in order. The bottom is going to be a 4, x to the fourth, y. Now, if you're looking at this, try to compartmentalize it. The 12 and the 4 reduce to 3 over 1. The x's have more on the bottom, so when we cancel these out, we're left with 2. And the y's, there's more on the top, we take out 1. So if it's easier for you to see this, clean it up and then reduce it. All right, 1b, same idea. This is a division symbol right here. So instead of writing it horizontally, they stacked them. So I have this 8a to the third divided by 5b to the fourth. Highlight that little division symbol. We're going to change it, change the sign of multiplication, and then flip. 15b to the fifth over 2ab to the third. So what's nice about this is it's nothing new. At this point now we are just cleaning it up. So this is a problem where if you have a calculator and you want to take your 8 times 15 and put that number there, that's fine. For me, I'm going to go ahead and build my fraction. And I'm looking to reduce any numerator in the top and any numerator in the denominator, or any number in the denominator. So 2 goes into 2 once, it goes into here 4 times. 5 and 15, 5 goes into 5 once, and it goes into here 3 times. So what's left is a 4 times a 3. This is all multiplication, that's 12. I'm going to keep my a to the third. I'm going to keep my b to the fifth. What's left in the bottom is just a 1. I have a to the first. But look, I have more b's. Do you remember what to do when we have to multiply the bases?
Nope.
Well, how many b's are there? There's 4 here and 3 here. So how many b's would there be if we wrote them all out? B the seventh. So when you're multiplying, you add them. Okay, now that we've got the variables cleaned up, I already reduced the numbers, so we know it's 12 over 1. Who has more a's? The top, so take out 1. There's 2 left up top, a squared. Who has more b's? So take out 5, and there's 2 left on the bottom. All right, I do not need the 1 in the denominator, but I'm keeping it there so when we do need it, it's there. Okay, so same idea. No,
Yeah,
we
that
have
made
some
a lot-
more.
That made a lot of sense.
Now, what's different about these examples? I mean, they look bigger, but what else is different?
You probably have to like
Do some stupid stuff.
subtract and like configure.
You're gonna have
hardest
to
thing
you're
of
gonna
all
have to
is
factor.
And, like,
On the front problems here, it was just multiplication and multiplication. We just had single fractions that we are dividing and we multiplied by the reciprocal. But on the back here, I can't go through and cancel these x's. I have to be able to take the x's out of all the terms, and I can't. So the minute I have addition and subtraction, I'm going to need to factor to cancel. So that's the difference there. Now, before I worry about factoring, I'm going to do my keep, change, flip. I'm going to keep the first fraction, x to the 5th minus 4x to the 3rd over x squared minus x minus 2. But instead of dividing, what am I going to do? Multiply by the reciprocal. Now, I'm not changing anything. However, when you get practice at this, you could factor as you do your keep, change, flip. I just want to focus on the keep, change, and flip. Now we need to factor. Okay. The factoring is not hard, but sometimes there's more steps. The first thing I need to do is look for a GCF. Do I have a GCF in this top one?
I don't know.
Yeah, I do. So I'm going to take that out. I have x to the 3rd. What's left? X squared minus 4. I'm factoring that above because it actually factors again. So I have that x to the 3rd. And this x squared minus 4 is going to factor again. And what does it become? I'd like you to factor it. The x squared minus 4. So x times x, I would need a plus 2 and a minus 2. That's how that numerator factors. So I'm just going to highlight that in blue so you match that up. Okay, I'm going to go ahead and factor this denominator. Now, there's no GCF here, so I'm going to jump in to that trial and error, but I don't have to try too hard because the factors of -2 will add up. I need one positive, one negative, and what numbers multiply to 2?
Probably 2.
2 and 1. Which should be positive? The 2 or the 1?
Probably the 2.
The 1, because I want it to add up to -1. All right, so that's been factored. Now remember, we flipped this. I have x squared minus 1. How does that factor?
0.
They don't have a GCF. Well, it's a difference of squares, though. If you look at it, this would be x plus 1 and x minus 1. So you're going to have to recall some of your factoring skills. Well, we're going to have to try. Okay, and then this bottom one right here, there's definitely a GCF here. The GCF here is x to the 3rd, and I'm left with x squared minus x minus 2. So I didn't want to rewrite all of these things, so if there's a GCF, I normally take that out, and I'm going to take this x to the 3rd, keep it, and now I'm going to break this down. And that's that x minus 2 and x plus 1. Okay, now, if you see I have the 4 pieces here, I need to see what cancels. So, first things first, this is all multiplication. Now that it's all multiplication, I can cancel any top to any bottom. So the x to the 3rd is going to cancel. Now, I have an x plus 2. Are there any other x plus 2's in the denominator? I don't see it, so I think I'm stuck with that. But you see the x minus 2 would cancel with that one. Now, it's a 1-to-1 ratio. I could cancel these, or I could cancel these, but not all 3. I have an x plus 1. That can cancel with this one, or it could have canceled over here. Does anything else cancel? Okay, so what's left in the top? X plus 2 x minus 1. What's left in the bottom? Okay. So you have done all of this before. The only difference is we started out with division. We changed it to multiply by the reciprocal. Then we factor and cancel. Now this one had a little extra with those GCFs. All right, look at example B. Same idea, but they're stacked. So do you see your big division symbol? This is your keep, change, and this is your flip. We're going to flip the second one. So I'm going to rewrite it without factoring, but if you're comfortable, you could factor as you go. So the numerator, x squared minus 9x plus 14. Still x squared minus 6x plus 5. But we're going to multiply by the reciprocal. So make sure you actually flip it. X squared minus 7x plus 10. Denominator, x squared minus 8x plus 7. Okay, now take a minute and see if there's any GCFs. I don't see any GCFs anywhere, so we're going to go into our basic factoring. And why is the factoring? Why am I saying it's basic? There's no GCF and A is 1. So in each one of these, it is going to factor. So we've got the x times x, and what multiplies to 14? 2 and 7. Now what kind of signs do you want? I need to be a positive 14, but add up to negative 9. Plus, plus, minus, minus, or mix, plus, minus. 2 minuses. So this is easier if you're good at factoring. If factoring is not easy for you, then that makes it harder. Okay, denominator, x and x. I need to multiply to 5. My only options are 5 and 1, and what did you say? 2 minus signs. All right, still times. Let's factor this numerator. So I am just going piece by piece, not doing it all at once. X times x, what multiplies to 10? I was thinking 2 and 5. Okay, what kind of signs? 2 negatives because they have to add up. All right, how about the denominator? X times x. The only things that multiply to 7 are 7 and 1. Okay, what kind of signs? Yeah, these all had to multiply to positive to add up to negative, so we needed 2 negative signs. Okay, you've done all the hard part. So what is the exact same that can cancel? It has to be top to bottom. Okay, hold on. X minus 7s, I agree. X minus 5. Now, I have some people that want to cancel out the X minus 2s. They're both in the numerator, so I can't cancel them. And same thing with the X minus 1. It has to be a numerator to denominator. So what's left? You could write X minus 2 times X minus 2, but I can write it squared. X minus 1 times X minus 1, or quantity squared. So you can only cancel if it's 1 in the numerator and 1 in the denominator. Okay, so go ahead and try the next two. So the first thing I did was I changed, and I flipped. Now, this one's a little harder factoring because that 2 out front. Can we agree on that? So you definitely had to put a little effort into it, not too much. My only options are 2x and 1x. Now, normally I put a 2 here and a 2 here, but remember how we talked about you can't have a common factor? So I'm going to go with a 1 and a 4, and I'm going to put the minus sign here. So I'm just playing with the numbers. I've got my first and last. The outer is -8 and the inner is 1. There's my -7. So if you got the wrong number, flip numbers. You got the wrong sign, flip your signs. Okay, the denominator, we should have no problem factoring. That's a difference of squares. Factors a -9 that add up to 0. X plus 3 and x minus 3. I already flipped it. But before I struggle factoring, did you look for a GCF here? I tried 8. It was too big. What else goes into all these? 4. 2, but I'm going to do 4. 2 works, but 4 is better. So what's left is 2x squared minus 7x plus 3. Okay, so I'm going to bring that 4 down on the outside, And then I've got to do a little thinking. This factoring is a little harder because of the 2. So I'm going to go with 2x and x. And the only things that multiply to 3 are 3 and 1. Now, I have a reason why I put it there, because I knew I wanted to build it to -7. So that's a -6x, and that's a -1. There's my -7. If it didn't work, we would try it again. Okay, last piece down here. Notice there's only 2 terms. This is a difference of squares. So we're going to go with 2x and another 2x. There's my 4x squared. I need a -1, so 1 plus and 1 minus. Okay, so double check your factoring. Now, if you factor wrong, your number or your sign, things are going to cancel wrong. So you always want to show this part, and even when you're canceling out, don't scribble it out so we can still see it. I see a 2x plus 1. The whole chunk has to be the same. Those cancel. What else can you guys cancel? This x minus 3 and this x minus 3. Anything else? I feel like there's one more thing. The 2x minus 1 and the 2x minus 1. Now, I have a 4 out front, but there's no other numbers out front. So what's left is, I'm going to put the 4 here, and then the x minus 4. What's left in the bottom? X plus 3. Now, if it helps you, you could go through and highlight what's left, and then you don't lose it. But whatever works for you. You don't have to redistribute this. You can just leave the answer as it is. Okay, so that one would take a little more effort because it had a little bit more factoring. All right, next one. Keep the first fraction, change that big division symbol to multiply by the reciprocal. Okay, this has a GCF, and like I said, normally if there's a GCF, I take it out up here first because it's going to factor again sometimes. So here's my x, and this is a difference of squares, a little more complex. 2x and 2x, 1 plus 3 and 1 minus 3. Okay, does this factor? There's no GCF, there's no x squared, it's just going to say as 2x minus 7. Keep my time symbol. Does this numerator factor? Okay. Is there a GCF? Yep, 2x. What's left? X minus 7. Now, the only reason I brought this down is I knew it didn't factor further. If not, I probably would have factored up here. How about this? Is there a GCF here?
No.
Yeah, not a number, but what about an x squared? They don't have a number, but they both have x squared. So what's left? 2x plus 3. Okay, all the pieces have to be here. You can't just get rid of something. So I messed up here, and this should be a 2 in here. So when I took out the 2x, I needed a 2x minus 7 there. If I wouldn't have had that 2 there, it wouldn't have canceled right. Okay, now the 2x minus 7's cancel. The 2x plus 3 cancels. And then people always forget, there's more that cancels. What else cancels? Do you see anything? No. You have an x here and an extra x here, and you have 2 down here. These 2 x's cancel, and they're gone. Now, if you didn't catch that, you could put it together. You can because it's multiplication. You can't cancel over addition and subtraction. So if it's factored, you can cancel any pieces. So what's left on the top is just 2x minus 3 and that 2. And what's left in the bottom? Nothing. So I just put a 1 there. So final answer, 2 times 2x minus 3. Now, if you would not have caught those x's canceled, you would have had a 2x squared up top and the 2x minus 3. In the bottom, you would have had that x squared. And then do you see that now we can cancel because it's all multiplication. Okay? All right. That is good for now. But I need you to look at this problem and find out what the error is. And then we will do these other problems starting tomorrow. So before you pack up, I need you to figure out what the error is. Both these start off with the same problem. Both of them are factored the same. Do you agree?
It's switched.
What switched? Like who's right? Is A correct or is B correct?
B's correct.
Why?
Because
B is correct, but why?
Because you need the
Okay, so when you canceled this out, where was the x minus 9 left? And the bottom, so 1 on top. This is the common mistake, so that is wrong.